I'm going to do a little review video here for Chapter 8. And I know usually I start right away with some practice questions in the back of the book, but I think this is just so complicated that I want to do a little summary of the Chapter 8 beforehand. So if you haven't read through the book yet and then watched the lecture and calculator videos on Pearson before this, make sure you go and watch those first. This is just supposed to be kind of a summary recap of everything in 8.1. Okay, so let's get started. In Chapter 7, what you would do is that you would be given a mean, and you'd be given a standard deviation, and then you would graph the distribution. The mean, of course, would be right in the middle of the distribution. The standard deviation would talk about how spread out it is. And then you'd be finding areas underneath the curve. Those areas representing the probability of getting a data value inside of that region there. In Chapter 8, we are still doing something very similar. But instead of just looking at getting a single individual inside of a certain region, we're going to be looking at finding a sample whose average is inside of that region. So we're creating something called a sampling distribution. You want to think of the sampling distribution is that if you find every single sample of size n, you find the average of every single sample, and then you graph those averages. So this number line is not just the normal data values. This represents the means of every single sample of size n. What's really neat is that if the original distribution is a normal bell curve, then the sampling distribution is also going to be a normal bell curve. And if you read through the book, spoilers, even if the original distribution is skewed one way or the other, the sampling distribution can still be normal as long as the sample size is big enough and that magic number is around 30. So as long as you're picking samples of size around 30, you're always going to have a normal sampling distribution. So anytime you have a normal curve, you need to know the mean and the standard deviation, and there are nice formulas for this. So this represents the mean of the sampling distribution. The mean of the sampling distribution is just the original population mean. The standard deviation of the sampling distribution is a little bit different. It's the original standard deviation divided by the square root of the sample size. Make sure you have these two formulas in front of you. There is a formula sheet that has these that I sent out a long time ago. But if you've lost the formula sheet, just make sure you have these, because you have to use these formulas whenever you have sampling distributions of means. Okay, now that we have that as kind of a little setup, let's now look at an example. So I pulled up the book. This is on page 388. We're just going to look at number 5. So this is in the back of Chapter 8 in the review section. Energy need during pregnancy. The total energy need during pregnancy is normally distributed with a mean 2,600 calories per day and a standard deviation 50 calories per day. Okay, so one thing I do want to point out is that when we take the final exam, you're not going to know whether these questions are coming from Chapter 7 or Chapter 8, so you need to be able to distinguish between the two. The key words for this question so far is that the original population is a normal distribution, and then it gives you the mean of that normal distribution and the standard deviation of that normal distribution. So this could still be a Chapter 7 question, or it could be a Chapter 8 question at this point. Okay, part A here is just kind of a going back to Chapter 1 kind of thing. Is total energy needed during pregnancy qualitative or quantitative? It's going to be quantitative. Quantitative because we're measuring calories, which is a numerical measure. Okay, so quantitative for that one. On to the more important ones. B, what is the probability that a randomly selected pregnant woman has an energy need of more than 2,625 calories per day? Is this result unusual? All right, big keys for this question is it's asking you to find probability, and then it's giving you a range. More than 2,625 calories per day. The other key to this question is that there's no sample that they're asking for. We're just looking at one randomly selected pregnant woman. anytime you're finding the probability of just a single individual, you're doing chapter 7 stuff. So let's do that just for some extra practice. So this was question 5. We're on part B at the moment. So anytime you're looking at just a single individual, you're going to graph the bell curve using the population information. The population information had the population mean was 2,600 calories per day. The population standard deviation was 50 calories per day. That was just given to us in the top part of the question. This part B is asking us to find the probability that the women that we select has more than a need of 2,625 calories per day. 2,625 is going to be very close to the mean. It's going to be about here, 2,625. And we want to be more than that. So we are looking at the area starting at 2,625 and going to the right. And this does go on forever. In chapter 7, we looked at a lot of different ways of finding this area. The easiest way is just going to be using the calculator. Anytime you're looking for the area under the curve, you're going to be doing normal CDF stuff. So I'll pull up the calculator here in just a second. Let's just go ahead and write out everything we need. So we're going to find normal CDF in the calculator, and then it's going to ask for the lower and the upper limit. The lower limit for this area is the starting point, that 2,625, and this thing goes up forever, so it goes up to infinity. In the calculator, I'm going to write it like this, 1E99. That represents 1 and then 99 zeros behind it, as big of a number as we can plug into the calculator to simulate infinity. The next two things that it asks for is the mean, which was 2,600, and the standard deviation, which is 50. Okay, so in the calculator, we're going to plug all that stuff in. Clear out this. To get to normal CDF, remember it's second and then the distributions. Normal CDF is the second option. Hopefully you have a menu. If not, it's okay. So we're going to type in the lower limit, the 2,625. The upper limit, which was that 1E99. The mean was 2,600 calories per day. Standard deviation was 50 calories per day. All right, and then paste. If you don't have a menu, just make sure you type it in, just like I wrote it up in the OneNote there just a minute ago. And we'll hit enter, and we get a number. So I don't know exactly what the decimal place would be. We'll just do 4.3085. And that's going to be our answer here. So the question was, what is the probability of choosing a randomly selected woman who needs more than 2,625 calories per day? There is roughly a 31% chance that we choose a woman at random that needs that many calories per day. Okay, let's move on to 5C. 5C is where we're going to start looking at sample stuff. So let's go back over to the book. C. Describe the sampling distribution of X bar, the sample mean daily energy requirement for a random sample of 20 pregnant women. What might be the source of variability in the sample mean? Okay. So we can ignore this second part, what might be the source of variability. That was a section that we didn't cover, but we do need to worry about this first sentence here. So describe the sampling distribution of X bar, the sample mean daily energy requirement for a random sample of 20 pregnant women. Now we're creating a sampling distribution where we're looking at it as samples of size 20. Every single different sample number is going to have a different sampling distribution. Here, looking at size 20, it's going to be normal. So this is going to be the sampling distribution of size 20. I know that this is a normal sampling distribution because the population is normal. It doesn't matter what the sample size is. As long as the population is normal, the sampling distribution is normal. It's only when the population is skewed that we have to worry about this number being big enough. Okay. So it's normal, it's going to have a mean, and it's going to have a standard deviation. The mean of the sampling distribution stays the same as the original mean of the population. Every single one of these sampling distributions is going to be centered at the same spot that the population is centered. But the standard deviation has changed. The formula, remember, is the old standard deviation divided by the square root of the sample size. So for us, the old standard deviation for the population was 50, and we're going to divide that by the square root of the sample size, so square root of 20. I'm going to go in the calculator here and just type in 50 divided by square root 20. And we get a number 11.18. You kind of want to take that to as many decimal points as you feel comfortable with, but you should be fine with just a couple. Okay, so this is it, right? This is the answer for part C. Anytime it says to describe a distribution, describing a distribution is to say whether it's normal or not, and we agreed that this is normal. Give the mean, give the standard deviation. All right, we can move on to part D. So D, what is the probability that a random sample of 20 pregnant women has a mean energy need of more than 2,625 calories per day? Is this unusual? I forgot to say if the original one was unusual. We'll go back and talk about that after we find this probability. Anytime you're asked to find the probability and they give you a sample of individuals, you have to use the sampling distribution, which means that we're using the same picture that we just made for part C. I'll just write it out here. So this is the sampling distribution of size 20. The mean of the sampling distribution is at 2,600. The standard deviation of the sampling distribution was that 11.18 that we found. We are asked to find the probability that the average of those 20 women that we grab at random is more than 2,625. So instead of just looking at a single pregnancy and having the probability of that single pregnancy needing more than 2,625 calories per day, we're going to be taking a random sample of 20 women, and we want the average of those 20 pregnant women to be more than 2,625 calories per day. Okay, other than that, this question is the same as the Chapter 7 part. 2,625 is going to be to the right of the mean, and we want to be more than that, so we want to be the area to the right. We're finding area, which means in the calculator we're doing another normal CDF. Lower limit is still 2,625. My upper limit goes to the right forever. Mean 2,600. Standard deviation 11.18. So I want to point out how similar this normal CDF is to this top normal CDF. The only difference is the standard deviation. So when you're grabbing samples, standard deviation is the only thing that's going to change. Okay, so we can type this into the calculator real quick. Oh, wrong button, sorry. So we'll get to the normal CDF. And again, the only thing we need to change is the standard deviation. We're going to change that to the 11.18. Paste, enter, and we get 0.0127. All right, this is unusual. Okay, so unusual is less than 5%, and here we're close to 1%. But I want to point out the difference between the answer we got here and the answer that we got up top. This was not unusual. This is close to 30%. It is not unusual for a single woman to need more than 2,625 calories per day, but it is unusual to grab a sample of 20 women and have their average to be more than 2,625. Almost a 1% chance of that happening. So when you're grabbing these samples, it is much more difficult for a sample's average to be far away from the mean. All right, I'm just going to add on to this video for the 8.2 stuff, and I'll make this one a lot quicker. So with 8.2, instead of finding means, we're looking at proportions. And we are still finding sampling distributions. But not sampling distributions of means, sampling distributions of these proportions. These still come out to be normal, and there's some guidelines for that. Look in the book for those guidelines. It's a little inequality that you need for this to come out to be normal. But if the sampling distribution for a certain sample size is normal, it's going to have a mean, which we call mu sub p hat. The mean of the sampling distribution of proportions is whatever the population proportion little p is. The standard deviation of the sampling distribution p hat, this is a pretty complicated looking formula. It is p times 1 minus p all divided by n underneath the square root. And again, make sure you have that formula with you anytime you're working on some Chapter 8 stuff. And then the only other thing is, again, the number line here doesn't represent data values. This number line represents the sample proportions based on our samples of size n. Okay, given this information, let's go and answer a quick question in the book. So this is on the next page, 389, number 8 here. A Gallup survey indicated that 72% of 18 to 29-year-olds, if given a chance, would prefer to start their own business rather than work for someone else. A random sample of 600 18 to 29-year-olds is obtained today. So this time, is the variable qualitative or quantitative? This time it's qualitative. It's qualitative because it's just a yes or no question, right? Would you prefer to start your own business? Either yes or no, a qualitative measure. But even with these qualitative measures, there's a ton of math that we can do behind the scenes with these sample proportions. Okay, so the next step is to describe the sampling distribution. So let's look at that. Remember that describing the sampling distribution just means to say whether it's normal or not, and then find the mean and the standard deviation. Okay, so the mean of the sampling distribution, remember, is the original population proportion. That is always given to you in the question. Here, 72%. So that means that my mean of this distribution is at 0.72. The standard deviation of the sampling distribution comes from that awful formula. So it's a big square root of p, 0.72, times 1 minus 0.72, divided by the sample size. And remember, we are taking samples of size 600. So we can just type that in the calculator. I'll show you how I would do it. I would just do square root of the 0.72 times parentheses, the 1 minus 0.72, close the parentheses, that divided by the sample size 600. So you can type it in just like that and it'll give you the right thing. 0.0183. I'll just take it out to 4 decimal places here. Okay, so that's it. Describe the sampling distribution. This is what you need. You need to say that it's normal. Take the mean and the standard deviation. All right, let's look at part C. In a random sample of 600 18 to 29-year-olds, what is the probability that no more than 70% would prefer to start their own business? Okay, so I'm going to be taking that same picture from above. This is the sampling distribution of size 600. The mean of this sampling distribution is at 0.72. The standard deviation of the sampling distribution is at 0.0183. Our question wants us to find the probability that we grab those 600 people and the sample proportion is no more than, I think it was 70%, I already forget. No more than 70%. No more than 70% is less than or equal to 70%, which is 0.7. Okay, so then we come back over to our distribution. 0.7 is going to be out here to the left of 0.72, and we want to be less than or equal to that, which means we want to find the area to the left. Okay, that's going to be another normal CDF. This time the lower limit goes forever to the left, so we're going to put a negative infinity in there. It's going to go up to an upper limit of 0.7, mean 0.72, standard deviation 0.0183. So we'll type that in the calculator. All right, so remember it was going forever to the left, so we'll simulate it going to infinity. It's going up to 0.7, or 70%, has a mean of 0.72, and that standard deviation we had calculated, that 0.0183. So we get 0.1372. And then that's it. That's going to be our answer for this question. The probability that we grab 600 people where less than 70% of them want to start their own business, roughly 13.72%. Okay, so there is another part to this one, part D. We'll do this one real quick. Would it be unusual if a random sample of 600 18 to 29-year-olds resulted in 450 or more who would prefer to start their own business? We still have the same sample size, and because the sample size is the same, that means our picture is going to be the same. But this time we want 450 or more to want to start their own business. So let me just copy that normal distribution down. The mean was at 0.72. The standard deviation was at 0.0183. We have to be a little bit careful about this question, because this question is asking us to find, we want 450 out of the 600 or more to want to start their own business. So before we do anything, we have to figure out what the proportion is of having 450 out of the 600 want to start their own business. So we'll just go to the calculator and take 450 and divide that by 600, and we get 0.75. So really what this question is asking is it's asking us to find all samples of size 600. What is the probability that the proportion of those samples is more than 0.75? 0.75 is out here to the right, and we want to be more than that. So that's a normal CDF. Starting at 0.75, going up forever. The mean and the standard deviation stay the same. Sorry, I'm getting really sloppy here. So we'll type that in. Oops, hit the wrong button again. So this time we're starting at 0.75. We're going up to infinity. Mean and the standard deviation stay the same. This time we get 0.0506. So if you were to go out right now and grab 600 people, there's about a 5% chance that of those 600 people, more than 450 would want to start their own business.